Alright, so we are going to spend some time now looking at those ecology problems that I wanted to go through with you. I think I'm going to do another video because we're looking at a lot of growth rate, but you also need to know some things about primary productivity, so my goal is to get another one of those made as well. So I wanted to show you, to get you guys started, what is going to be given to you on your test. So I took a snapshot, I cut and paste here, of your formula sheet. So this is just exactly what you're going to be given on your test for your formulas. And what I want you to do here is you're going to want to pause and you're going to want to write down what each of these things mean, what each of these things tell you. So you're going to pause and do that. Alright, so hopefully you've written those down to get you started. So the dy stands for the amount of change in a population. The T stands for time. B stands for birth rate, which we're going to talk about how you calculate that in a minute. How you calculate death rate. N is going to represent population size. K is going to represent carrying capacity, which you should know about at this point. Hopefully you've watched some of the other videos. And then R max is the maximum per capita growth rate of the population. Okay, so a little bit more about those formulas. So one of the things that we see here is this D. So this D is going to represent delta, which you know from your Gibbs free energy equations means change. So it's like we're looking at the change in the population over a certain amount of time. R is going to represent the rate. In this case, this rate is going to also be called the per capita growth rate. So you can look at the per capita birth rate and the per capita death rate. So it's essentially trying to look at, for every individual, how many new individuals are being born, and then same thing with death rate. For every individual, how many are dying. Okay, so B we know is going to represent birth rate. And then this is how you're going to calculate birth rate. Birth rate is going to be based on the number of births divided by the total population size, which is essentially N. So you take births divided by N. And then M, sometimes you'll see M is going to represent mortality or death rate, which means the number of deaths per the population size. So you take the number of deaths divided by N, or the total population. Alright, so what we're going to do today is we're going to take some time and go through some examples of these problems. And then at the end, I'm going to give you, on your paper here, you're going to get a list of some other example problems to do. And I am planning on putting up just the answers for those problems on my website. So you can get to that and be checking out those answers. I'm not going to put exactly how to do them because I think you need to make sure that you know how to do them. But you can refer to that to make sure you have the correct answer. And try to get some help if you need to, if you're not getting the correct answer. Okay, so the first type of problem that we're going to look at is looking at calculating individual or per capita growth rates, which we really just talked about. So we've got a situation here. We have a population of 750 fish. 25 die on a particular day while 12 were born. So it wants to know what is the per capita death rate for the day, and it's telling us to round the nearest thousandth. One of the things when you're going to take your AP test is with those free response questions, you're going to have those, with your grid-in questions, you're going to have those grids where you have to fill in the numbers, and they're going to be looking for, did you round correctly? Did you round the way you're supposed to? The way they asked you to. So make sure you're thinking about rounding when you do your calculations. Okay, so let me see. I'm going to try to get to my camera that I've got here, and I'm going to show you what we've got going on. Alright, let me see if I can make this full screen. Here we go. Try to adjust this just a little bit. Okay, so we had a population of 750. So that means our N is 750. And then our births, we had 12 being born, and we had 25 deaths. Okay, so the first one wants to know, what is our per capita death rate? Okay, so to figure that out, we need to calculate death rate to get us started. So when we are calculating death rate, we are going to look at, just like we talked about just a minute ago, we're going to look at the number of deaths divided by our total population. Okay, so we are going to take 25 divided by 750. Okay, and then you can see here, I'm going to get 0.033. Okay, and that's where I'm going to end because it's the tenths, hundredths, and the thousandths place. So that would be my answer for the first part here. Then we're going to do the number of births divided by the total population size, which we get 12 divided by 750. Okay, and when we do that, we end up with 0.016. Okay, so this was our per capita death rate up here, and then per capita birth rate. Oops. Okay, so essentially that's telling us for every individual in the population, 0.033 individuals died, and then for every individual in the population, 0.016 individuals were born. Okay, so let me go back to my presentation here, my Prezi. Okay, and the next thing we're going to do, we are going to look through calculating population growth rates for exponential growth. Alright, so one of the things that you need to remember is what is exponential growth. So hopefully that's one of the things that you have learned about and we've talked about. So I'm going to show you and just remind you here, this is a graph showing exponential growth. So this is essentially showing we've got an infinite amount of growth. When we have exponential growth, we have to assume that there is an unlimited amount of resources. Because if there was any limit on the amount of resources, eventually this population would have to level off in its growth. And right now it looks like it's growing infinitely. Okay, so right now this population is growing infinitely or exponentially. So that's what we're going to assume. Oh, sorry, I gotta go back. Alrighty. So we are going to try to calculate the population growth rate for a population that is experiencing exponential growth. This population is going to have a size of 50 to start. We had 10 births, 4 deaths, and we've calculated that we have a rate of 0.12. Okay, so to calculate the population growth rate, if you look on, let's go back for just a second. Let me get to it. Okay, so it tells you on your formula table, it tells you what equation to use. So this one we're going to assume is exponential growth. So we have dn, which is, I'm just going to write the triangle here. So change in the population size over change in time. This is going to be our population growth rate. That's what we're going to look at. we're going to get there. Okay, equals R max times N. Okay. So let's go ahead. Let me get back to my camera again. I'll be flipping back and forth here. So, alright, so we got our population growth rate. And I'm using the 1 for exponential, like we saw on our formula table. So in this case, we were given R, and we were given N. So our R, we were told, was 0.12, and our N was 50. Okay, so all we're going to do, we're going to take 0.12, and we're going to multiply it by 50. Okay, so let's see what happens when we do that. Alright. So in this case, we got 6. Okay, which means that there are going to be 6 individuals added to the population in one generation. Okay, based on that growth rate that we calculated, that we figured out, we were able to find out that it's in the next generation, we're going to add 6 more individuals. Okay, this is if it's growing infinitely or exponentially, and we don't have to worry about limited resources. Okay, so let me go back here really quickly. Okay, so remember the other type of growth that we have is going to be logistic growth. So logistic growth, we're going to zoom in here, and we got a graph of logistic growth. Okay, so it starts out exponentially. We start out as that J-shaped curve, and then it's going to level off, and it's going to become an S-shaped curve. Okay, so logistic growth is going to be most of our population, because most of our populations don't have an unlimited supply of resources and supplies and habitats. Okay, so most of them are going to have a limiting rate. Okay, so our carrying capacity, remember that carrying capacity is going to be represented by the letter K, and carrying capacity is going to be the maximum amount of individuals an environment can support over the long-term amount of time. Okay, so when we're calculating growth rate, we have to take in carrying capacity into account. Okay, so this time, we're trying to find population growth rate again. Okay, but this time we've got to do it for logistic growth. Okay, we know our population size is 50 again. That we have 10 births and 4 deaths, just like our population last time. And we're going to have the same growth rate. Okay, and we're going to see what happens to that population size when we take into account carrying capacity. Okay, so let's look back really quickly here, and let's look at our formula sheet. Okay, so our formula sheet, we're going to use that delta N divided by delta T. Okay, that's going to tell us our population growth rate, and it's going to equal R max times N times K minus N over K. Okay, I'm going to go ahead and stop, and then when we get to the next video, I'll pick up where we left off here.